Today's title, Optimizing Furnace and Fired Heater Performance to Reduce Energy Cost, Operational Risk, and Asset Degradation. In other words, for me, it says we're elevating and we're sustaining reliability. And by virtue of that, probably your profitability comes right along with it. So as the industry moves towards longer and longer run cycles between turnarounds, it becomes even more important to protect your assets and prepare them during that precious turnaround window. Now, our panel today really has extensive experience in oil and gas and petrochemicals, right? And frankly, I know they both have worked very diligently in their own roles because they have very unique challenges on both sides of the fence, right? Their job is to find solutions. They've got to get them put into the thought process and into the funding process. And then when those things are done in turnarounds, they also have to stand behind them and measure those outcomes. So there's a good bit of pressure that comes with the kinds of jobs that these folks carry every day of the week. And so with that little bit of bragging about them, I'll say that number one, John Curry, I'd like to introduce you first, process engineer for fired equipment as a corporate subject matter expert at Citgo Petroleum. John, thank you for joining us today. And I know that your experience, which is pretty extensive across the process optimization world, that's really a hard skill set to find. And so I thank you for giving us the time today to join us. John, could you just say hello to make sure I've got the right volume and we're set up? Are we good?
Okay. Hello, everyone. I'm excited to be here and share thoughts and hopefully, as we go forward, get through this presentation, you guys feel a little more comfortable about, what you may or may not be able to do with your fired heaters to make them a little more efficient.
And to your point, John, thank you for saying that, because we will have at the end follow-up questions, and we can also be reached later. So it's tough to get through every question typically, so feel free to open up a conversation down the road too. Our other speaker, Jason Byers, your senior category manager at plant services at TPC. Now, Jason, your experience is quite broad, in meaning the Dows and the Shells and the BPs of the world. So that has really exposed you to multiple disciplines to deal with and strategies, and that's a pretty big footprint. So from the contract strategies and timelines and labor sourcing, all those things also get folded right in with what John has to do. So the two of you are almost the perfect match of what happens to get to a turnaround and get through it correctly. So thank you both for joining us. Jason, would you also give me a little voice check here and say hello?
Thank you, Larry. Yeah, I'm excited to be joining the conversation. I think I'll be able to give a different perspective, especially as it relates to kind of the commercial and economic impact that these turnarounds can have.
Yeah, it's all about the days and the dollars, right? Both sides of that equation make a big difference. All right, so then I'll go ahead and introduce myself, Larry Emsch, Director of Technical Sales for Integrated Global Services, particularly in the thermal efficiency group. That's a group that's focused on process reliability and ultimately the efficiency of different process trains, right? Our work is really about debottlenecking process trains, so you would be talking to us well ahead of a turnaround. Because our IGS technologies is all our homegrown equipment services, we would help you with our robotic equipment for defouling Texas towers and convection sections, or our patented vacuuming process for SCRs and fine particle screens. We've got ceramic coatings to help elevate efficiencies in certain fired heaters. And of course, as we all struggle with these longer and longer run cycles, we have a whole menu of hot tech services, which is online repairs, online maintenance, which can hopefully keep you out of that unplanned event. And so that's part of what gets folded into the thought process here in terms of how we can assist. So I'm going to go ahead and pop over to the first panel question. John, I'm going to pivot to you first. So when I think about I think about fired heater performance. There's always a gradual decline in the efficiency of the units between turnarounds. Can you talk a little bit about your experience as far as the early indicators of performance and how that helps you like maybe flag for the turnaround?
Absolutely, Larry. It's really you really hit the nail on the head when you're talking about turnarounds basically moving to longer and longer periods. And so when you're measuring, what you're looking for, and you can see that, that happens typically very, very slowly. That degradation typically happens very slowly. So unless you're monitoring longer term data, it's very hard to see. So that's why, a lot of times, it's just overlooked because they just don't see it happening immediately. It happens over years. And that typically is maybe a crossover temperature that they see declining on the process side from the convection section and the radiant section of a fired heater. That happens very slowly. So you've got to be able to monitor that data longer term. Some of the other things to that will indicate that some of the issues are going on is just time mostly. Brand new heaters are usually built very tightly, right? And so they're very easy to control. Older heaters, been some issues with them. The refractory degrades over time. Inlet and outlet, penetrations are not sealed. So things happen. And then the refractory, as it begins to slough off, especially KO wool type material, will actually lay down in the convection section on the tubes, and you don't see that. Again, it happens very, very slowly. And so the key is understanding the original design of the heater. If you got that outlet temperature, crossover temperatures, and be able to monitor that and understand that if that fired heater's not operating as it's designed, you probably need to start asking questions. Then comes the point where hey, maybe there's something we can do in this next turnaround to get some of that efficiency back.
John, you're talking about these headwinds, right? That you're facing and this issue. As the windows get wider, does that also force your hand on making decisions between repair or replace equipment? Because I feel like that might be part of this too.
That is. I mean, of course, you want to maintain your equipment as kind of original design, right? That's the cleaning. That's the external cleaning, the internal cleaning, to ensure that once you do come up out of a turnaround, and a lot of this is done offline. Some of the things we can do online, right? But some of the things we have to do offline, we got to be prepared. And so we want to get, make that heater kind of back to its original conditions after an outage. Outside of that, yes, there are things that begin to degrade over time. Tubes need to be replaced. Refractory needs to be replaced. Those kind of things happen. It's a lot of that's reliability driven, creep life on radiant tubes. And then, you may have carburization on extended surface area tubes in the convection section. That just happens over time as you're firing harder and harder because you are starting to foul. You're pushing hotter temperatures up into the convection section that are going to potentially be hotter than what the tube metallurgy is designed for, the fin metallurgy, and it's going to get damaged. And so you've got to be on top of that and be aware of that over time and be prepared for that during the next turnaround, that you can be proactive and not get in there and have discovery work, which is then going to stretch the turnaround out. And we don't want that.
Gotcha. Yeah. My only last comment there you made me think about long-term, and all of a sudden you're in a CapEx discussion too, right? If you're replacing tubes and things like that, that really has a much bigger financial roll-up implications. I'm going to roll into our next panel question. And so we talk about fuel savings, we talk about a lot of emission reductions and things like that, but how does the heater's inefficiency, does that actually slip into operational instability? I mean, I guess I'm thinking at some point, does that decline start to get into a safety exposure or a safety alarm scenario, right? I mean, does it go that far?
Absolutely. If you are running a heater outside of its design conditions, sooner or later, because of the fouling that's happening, maybe oxidation externally on the tubes in the radiant section, coking on the internal, you are now firing that heater harder potentially than what it's designed for. When that happens, then you're getting into being short of air, starting to see combustibles or unburned gas in the box, and then you're into what can be safety issues. You can also be overfiring the heater or the burners to a point where they become unstable and actually will extinguish themselves. Now you're really in a pickle because you've got unburned gas in your fired heater. So we really the key and what we're talking about is the safety exposure is that in time, most owner operators are putting in advanced safety instrumented systems to be able to help that console operator that's running that fired heater, help him out to identify unsafe situations very quickly and hopefully park that heater in a safe state, or if they need to, actually trip that heater out. So again, we've talked about this in the past. Because a heater is designed for 3% O2 or about 15% excess air over what it's designed for, doesn't necessarily mean you can operate there. A lot of things can happen to make you basically chew up what existing O2 you have in that box. Now you're getting into an unsafe situation. So the idea is to find a safe place to operate that heater, depending upon its age and what have you, so that you're still efficient, but you're also being safe and reliable. Today, safety and reliability trumps efficiency almost every time. But again, they do all work hand in hand, for sure.
Yeah, it is every day of the week, right? The safety drives the decisions and the priorities. We just have to be able to recognize them, because that's really the most important part, especially early on when you have slow issues like that developing. I'm going to go ahead and move over to question 3 now, but it made me think about, John, that last comment about it's very common for us to get calls from customers where they'd like us to insert our technologies between turnarounds just to buy some breathing room, right? Because that turnaround may be too many months away, and that deficit that they're running at can be problematic, and that's often a good place for our online people to help. But you made me think about that match.
At a synthetic fuels manufacturing facility, 2 identical platforming heaters were suffering from elevated stack temperatures and less than desirable steam production. Following a detailed evaluation, it was determined that the problem was being caused by fouling in the convection section. Hot convection section cleaning was performed while the fired heaters were in operation. In order to gain access to the convection section fin tubes, a proprietary TubeTech hot access creation method was used, with 48 reusable access ports created to facilitate the cleaning. The cleaning was completed while the plant was in full operation, with no disruption to production, using an environmentally friendly service that will not damage fin tubes. This resulted in a decrease in stack temperature of 36 degrees Celsius and an increase in steam production of 0.9 tons per hour. Improved fired heater efficiency and furnace draft, increased processed preheat and steam production, and reduced stack temperature were achieved. Internal rate of return was 31.33%, with a return on investment of 30 days.
So the leading operators in the industry, the people that are really running these very complex facilities, I would imagine, and I like your comment, John, about this, I would imagine they are in a big way trying to be more process driven, right? They're folding in different softwares, they're trying to do engineering models, predictive maintenance. I mean, doesn't that all come into play for you, maybe not identifying a limitation, but tracking it? I mean, how fast, how bad is it going to be? Is that a big part of your day or your team's day?
For sure. I mean, we do have teams that are looking at fired heaters. I wouldn't say continuously, but we are monitoring. And of course, any, good heater monitoring program, if possible, you're going to need real-time tracking and trending of your heater efficiency, your O2s, your stack temperatures. From that, you can calculate heater efficiency, and you can trend that over time to see if that efficiency is starting to drop. That will be your first clue that maybe there's something going on with fouling in the heater. Of course, tube skin thermocouple monitoring, that's a key. That'll tell you if you've got potential scaling or oxidation or internal coking happening. And you want to make sure and position those tube skin thermocouples at the edge of the flame envelope where the burner flame envelope is going to be at its peak temperatures. And that peak flux on the tubes is where you've actually got those mounted. If you put them higher or lower in the box, they're not necessarily going to give you a good indication of what's going on. So the installation and proper location is key to good tube skin thermocouple monitoring. Infrared surveys. You definitely want to combine that with infrared surveys because that tube skin thermocouple is going to catch what's going on around that point. An infrared survey can monitor the entire length of the tube and each of the passes. And then, of course, most companies today do what we call annual boiler heater MAC tune-ups. That's where the experts go out and they physically get on each and every heater. They look for all the concerns that might be an issue. They attempt to tune the heater up and look and see if there's issues wrong with the burner, something wrong with the burner, something wrong with the heater, stack damper maybe stuck, whatever it is. They note that. They get back with the area people as they're building their turnaround scope. If it's something they can't do immediately, has to be done during turnaround. They make sure they get notifications in and follow up with that to get those on the turnaround list, get the materials they need to fix whatever the issues are on those heaters. So again, those annual boiler heater MAC tune-ups are very important to the turnaround schedule as well. And of course, looking at all these, the operator is going to be able to effectively manage the heater while it's in service, and then of course plan for those maintenance activities in the upcoming turnaround.
So you're actually always building your list.
Sure.
That sounds like it's a continuous scorecard of prioritizing these things.
Absolutely.
Because the thermal, I mentioned that we're on a thermal efficiency program, if you will, and that's one of the things that we provide are the audits for that, because we often get approached to debottleneck or provide options of what we could do.
At a catalytic reforming unit in Poland, tubes experience oxidation scale formation on the external surfaces, creating poor conductive heat transfer through the tube wall to the process. This leads to overfiring and high bridge wall temperatures, eventually resulting in a limitation and reduced production rate. To address this, high emissivity ceramic coatings were applied to both radiant tubes and refractory surfaces during the 2022 turnaround. After application, a sizable decrease in tube surface temperature of 40 to 60 degrees Celsius was observed, along with more uniform temperature distribution along the tube length. The C-Tech ceramic coating, applied to the refractory surfaces, also improved radiant heat transfer efficiency to the process over design conditions. Data analysis also showed that even with a 7% increase in throughput, bridge wall temperatures in each cell were lower than before. This resulted in a weighted average bridge wall temperature reduction of 20 degrees Celsius and fuel savings of 1.26 gigacalories per hour. Overall, the application achieved 5.8% fuel savings under the same production, or a 6.2% production increase under the same fuel firing, with a rapid payout of fewer than 12 months.
Even as benign, if you will, of just tracking your CO2 reduction, right? I know Jason's well aware of how many many annual reports have the tally of CO2 reduction in them, right? And what kind of fuel savings and all of those things that roll over to the commercial side, because that facility's built to not only make product but provide a return. And so it's important that you fix what needs to be fixed, and luxury items might be a little different decision in those kinds of situations. Jason, was there anything that you saw on these when we do these annual audits or we make these recommendations? Do those packages start to get to you early, meaning ahead of turnaround? Does that sort of put you on a target list also?
Yes, we normally get some of these packages, in early stages of the gate reviews, so we can understand the cost and the economic impact to finish getting the business approval to move forward.
Sometimes customers have told me, hey, we have a new strategy after this turnaround. I would imagine that's also that comes from your side, right? We're getting a different feedstock, or we have a new octane requirement or a new volume requirement. I imagine that's coming from your side and pushing that back over to John's decision making. Am I imagining that? Is that fair?
No, that is a fair assessment. Yeah. So after the turnaround, they might reevaluate some things. Say, hey, look, we need to pivot. We need to switch strategies for next time to increase our rates or whatever the impact is going to be.
Yeah. How do you tell the future, right? Isn't that the hardest thing in the world? What are we going to need in the next 7 years, right? I mean, market conditions being what they are, it's quite a ride. So let me go ahead and flip over to the next panel question. So Jason, maybe you can take the lead on this one first. From a turnaround and procurement perspective, what typically drives these scopes, especially when you think about scope growth late in the funding decision, late in the final prioritization? Because I'm thinking that what John's doing diagnostically, he'll bring the list to you, but isn't there this balance between we have X number of days to do this work? Isn't there? I'm trying to understand how that works out, because there's got to be a lot of discipline between both sides of the house. What does that look like from your experience, Jason?
Yeah, there is. So if we're looking at it from strictly a purchasing perspective, a lot of times the late heater scope growth, the creep, comes back to either incomplete or unknown diagnostics or some inspection that wasn't we didn't have the good inspection data in some of the tubes. So some of the refractory condition is unknown, or it's in a worse condition than what we expected. Same going to the burners, the situation with the burners, or maybe some of the structural steel inside the unit. So when we're doing a lot of this pre-planning, a lot of this comes to making assumptions, right? So some of the appropriate assumptions. And then when we open up the units, we say, hey, were those assumptions correct? Or were they not? And oftentimes, we're going to hit some of that discovery work that we didn't even have in the plans that we didn't expect. So that kind of puts us on the commercial side where, hey, wait, we might need to pivot. Do we need to expedite more material? Do we need to get additional craft resources to meet the schedule? Can we meet the schedule? What does this mean, and what does this look like from a cost standpoint, from an economic standpoint? Does it make sense to get the unit up on schedule running if the cost of the additional material and labor equal that, right? So those are some of the things that we got to think about. And I guess kind of what we need to do on the purchasing side is kind of push for maybe some added diagnostics to maybe see what can we do to partner with the business, to partner with our engineers to get a better scope definition. Is there any other additional inspections we can do, or can we peek in the manways to see what can be done to get better data?
Well, John, I think you just heard the word discovery, right? Discovery work in that description from Jason. He certainly felt the shock and awe of having to overcome those kinds of things. Would you want to make a comment on the discovery
Yeah,
work?
very much so. It's very important based on your turnaround scheduling and cutoff dates for engineers that are out monitoring equipment to know when those cutoff dates are to get work into the system and do that upfront, what we call pre-turnaround inspections, to get the list together, to work it through your area guys, to then get that placed into the turnaround. Now, again, that doesn't necessarily mean it's going to get done, because now, Jason's looking at, hey, I've got to manage this. I've got a pile of money here, and you're asking for more than the pile of money I have. We need to we need to prioritize. And so, but it is key to get equipment that you believe is going to need to be replaced or repaired or maintained to some extent during the turnaround, get it on the list so that they can account for it. The discovery word is a really bad word, and we do not like to get into equipment and find all kinds of things that need to be repaired, because then now you may be critical path. And since I'm the heater guy, I don't ever want to have the heater be critical path in a turnaround. My goal is to make sure that does not happen. So I want it to be as soon in the process as I can to get what I feel needs to be done on the list so that I'm not critical path.
Yeah, you never want to go to that meeting that's labeled critical path / discovery work. Understood. Exactly. That is a tough gig. And one of the things you made the mention earlier, Jason, about added diagnostics. And one of the things that we provide at IGS is we have our own high temperature camera, a lamp scope. And I remember the first time I used it was in a glass factory for making float glass. And so we could put that into a live unit and literally look around the corners, exceptional zoom capabilities. So we can do a lot to uncover those hidden damages. How far is the refractory failed, which may not be seen well enough because there's just never enough doors, right? Things like that. So to your point, all the diagnostic work up front we can possibly do just makes a better turnaround event for sure. Thank you for those comments. Panel question number 4, how do contracting strategies and picking a vendor and the labor decisions and rental equipment, I mean, all of that has some influence on the long-term performance of these units and how long the actual event is. Jason, why don't you take us down that road on things? I'm sure you've had direct experience, whether it was at Dow or BP or Technip. What would you say to that?
Yeah, so I'm going to say the first thing that I think it all relates back to having a good partnership with our vendors, right? Because our contracting strategy and who we select to do this work have a direct impact on our heater reliability after the turnaround is complete. The biggest mistake that we can make is treating just the heater work just like a commodity, because it tends to be more specialized, right? More specialized equipment, more specialized welding, specialized tubes, whether it's on the convection or what. And the work brings a lot of the technical experience, and with like the installation of the refractory and the tube replacements and making sure that we align the burners correctly, right? So a lot of this is making sure that the vendors we select for doing our heater work isn't the vendors that we might use for other type of general mechanical work that we use in the units. I mean, this is going to be somewhat, I don't know, so some of my colleagues might not like me saying this, but we don't always want to go to the lowest priced vendors, right? Because these are more specialties, and we want to make sure that we get quality work with a good performance. So we need to make sure that we do a good job of evaluating our contractors in partnership with our technical folks, right? Because we want to look at the technical evaluation as well as the commercial evaluation. So we need to make sure that they can execute this work and have a resume of other work that they've done that's very, very similar to this. So we need to make sure we plan well.
Yeah, I can't think of a tougher situation when you're asking for just a few more shifts. You're extending a timeline. That's brutal, right? It's also problematic to finish, to finish too early and not have the next contractor ready, but that's a much better problem, right? You're in a better situation. But to your point, you never want to pick vendors with the risk of extending your timeline or having the inexperience. I mean, that's just brutal. John, any comments on that, on that direction? Because the thing that came to mind for me was, yeah, the thing that came to mind to me was post reliability. I heard Jason say, and that means that when it's all said and done, you have to go back and prove that it was a good spend, prove that it was safely executed, right? Those meetings can be pretty tough after a turnaround. And so you want to do everything you can up front to make sure you have that high degree of success. You have a safe execution. And at the end of the day, what you put in is going to last for the next run. There's nothing worse than seeing refractory fail, right? 6 months after you come out of a turnaround when you replace 20% of that already. It just makes you crazy. And so it's important to choose wisely, as they say. I'm going to, and I don't want to cut you off.
I mean, it's to Jason's point, you've got to have that great relationship, right, with your vendors, knowing that when you give them a job, that it's going to be done safely and efficiently, and it's going to do what you told management is going to do.
And I guess I'm okay if it sounds self-serving, but that's actually our business model, because not only do we invent these technologies, but we're the applicators. So you never have to worry about pointing fingers of, it was a good idea that was poorly executed, right? We're going to be part of those post validations, because that's the right way to support the industry. You've got to be boots on the ground in the turnaround and afterwards. Otherwise, you don't come back, right, in these turnarounds. Excellent. I'm going to go ahead and go over now to panel question number 6. So when prioritizing heaters, Jason, I should take the lead again. When prioritizing heater upgrades or corrective actions, is there certain data that John should be elevating to the C-level folks, to the procurement folks, to the commercial folks? Because at the end of the day, you've got to secure funding, right? And how does that get unbundled on your side of the plant, Jason?
Yeah, so I mean, I think prioritizing our upgrades and knowing what we have to get done first is going to be key for the business to get the funding and for us to start helping with the scope development and identifying the correct strategy. If we got an idea of, hey, this is the most critical that we need to look at, we can start already having those discussions, not only with the business but with our contracting partners to identify the right people that we want to reach out to for this.
Is there a good bit of pre-qualifying work? I mean, things like that? I'm not sure.
There could be depending on what it is. Typically, we already have kind of a bucket of contractors, if you will, that can do some of the specialized work.
Okay.
And that's what we can go out to bid with. If it's anything outside the norm, then yeah, there will be some sort of pre-qualifying that we'd have to do beforehand.
Well, without telling tales out of school, I'm trying to get a feel for the push and pull, right? Because it's easy to say funding, we don't want to spend the money, and process wants everything. They're exaggerating at what they need. And there is a sensible middle there somewhere. How do you guys find that? John, did you want to talk a little bit about that? Because I know that you've got to have a huge need, a list of things you'd love to do, but not everything is affordable, right? It can't fit into the days available. Right. So you're doing probably some of your own first cuts.
So yeah, I mean, our projects are typically, like most owner operators, divided by safety, environmental, strategic, and or energy projects. Of course, priority-wise, safety environmental projects, typically you're going to get priority over a strategic or an energy project. The other piece is the ability to separate the economics on your internal rate of return for a capital strategic project versus an energy project. It's very nice when you have that split and not, a real high expectation for an energy project. Gas prices in the United States today are in the $3 per million BTU range. Very difficult to push a standalone energy project, right? Especially when you're competing with environmental and safety projects that have to be put in, right?
Right.
Now you're trying to push an energy project that it doesn't get lumped in with all of the strategic projects. There's a lot of really nice strategic projects that have really high rates of return, internal rates of return. Most energy projects do not. So there's a push to, if you have an energy project and it's standalone, it typically has a much lower IRR. So those are the good projects to go after. But unfortunately, because of energy prices, you almost have to lump those together as a strategic / energy project, even with some safety, even with some environmental. So I've even in my career taken a safety project or an environmental project and lumped in some energy or some strategic aspect to it in order to get that project pushed through. It's a safety project, but hey, it's got some other benefits as well. So you got to look at it in that perspective. And again, most projects, if I look at them just back of the envelope, if it pays out in less than a year, I'm typically going to push it. If it pays out in 3, 4, or 5 years, I'm probably not going to give it the time it needs to try to get it pushed through because it may not go. So I lump my projects priority by how fast I think they can pay out, to get them done. And that's where I'm going to spend most of my time. Again, like I said, the $3 gas in the U.S. is made it very difficult to push standalone energy projects.
Yeah, I can imagine. I've been to sites where it's $1.50 for gas too, right? And also, in Japan it's 12. Right? So I can appreciate the range of internal rate of return you can have just based on that, just on the fuel price itself. And so an energy project tallying in emissions, like in Europe, we see a lot of CO2 being tallied up and put in as a secondary benefit, because those are the things that we can prove with our process engineering side. We can tally up all of those benefits. And to your point, generally we see that in the world too. If it's a 1 year, 15-month payback or under, it's on the A list, right? And it really is something that's given serious consideration. And folks like Jason are at the table going, how do we get that in there? Because it's such a win in terms of an internal rate of return. And I don't know how it looks to you, Jason, but I also, John used the word strategic, and maybe for me it's optimization. But when I see customers adjusting the train to take advantage of the market for the next 5 or 8 years, I see that as almost coming over the top of everything. And actually even sometimes extending the turnaround, right? Getting more funding. Have you seen it that way?
That's actually very, very common. If we're going to optimize something and get it to run at higher rates, a lot of times, especially as far as the business looks at it, that takes priority. Is just right there after safety or emissions.
So if John doesn't get his new burners, it's because of that. It's because of that, right? That's how. So it's that trade-off. Right? It won't be it won't be the last, right? But that's really the balancing of the whole facility, right? You've got to do that too, because you've got margins to meet, you've got production levels to meet, you've got new feedstocks that might change your profile, and all the things that come into play there drive those decisions. It's never really clear to me how much interaction there is, but but you're giving me a much better feel for what that looks like, because you really do have competing obligations in a way. I mean, ultimately you don't, but getting there sounds like it's very important to have very candid conversations. So we're coming up on panel question number 7 here. Certainly we're more than halfway through this. And I think you guys are doing a great job of helping us get the big perspective. And I would just want to add in there that the process of justification seems to be where a lot of that heavy lifting is. And that is something that we do every day of the week here at IGS. We sit at the table with process engineers around the world and help them sort out those priorities and figure out those rates of return, because it does make a difference. It does make a difference in helping you prioritize, because you may not do, in your case, John, burners, right, in the next turn, but 4 years from now, 6 years from now, burners come to the top of the list. So you are gaining on it across the board. And so when a facility optimizes their heater performance, are there, I guess I would say, are the returns realistic? Do you actually see them? Are there real thresholds that you absolutely have to meet, Jason, or you won't even look at a project? You know, John said something about north of a 1-year payback, it starts to fade in terms of support. Do you have a similar threshold that you see in your experience? Are there jobs Go ahead.
No, that's all right. No, we typically look at what the overall payout is for the lifespan, right? So if your turnarounds are typically every three years, maybe five years in some instances, and what type of economic impact will we get over the lifespan of that 3 year, right? And into the next turnaround. Does it make sense? Does it, pay for it? And that's a conversation that's done between us, commercial and the business units to understand what's driving that.
We've gotten pulled into jobs where if we could extend the life of something, like the refractory is an easy example, where we could use our coatings to extend the life. It's so hard to get the days and dollars in the box to do the work. If we could add a whole nother cycle and not have to replace 20% of the surface area, that's just invaluable. And that's an important part of, to your point, there's various definitions of longevity. And it can be that simple too, to help you with that. John, anything else on the longevity side of this? Because preventative maintenance and all the things that come into play there. Do you know, when you've got to, let's say your hydraulics are a little light, or they're not quite giving you everything you need, are you picking out equipment way ahead of time to make sure you can just drop it right in? Do you have those sort of equipment goals?
Yeah, and you're looking at your preheat train, hydraulics through there. Sometimes you can potentially upgrade exchangers to run them at a little bit higher pressures to be able to get more throughput through the preheat into your fired heater. So yeah, there are things you can do hydraulically. And again, you also want to make sure that you have a very good symmetry between the passes as you're bringing process fluid, let's say a crude, into a charge heater, that you've got very good symmetry, in other words, and you're also not vaporizing potentially before you get there. So that's all pressure flow related. And so there's a lot of studies that are done to ensure that you're at the right pressures and temperatures for the flow regime that you're looking at prior to hitting the fired heater. And there's a lot of work that goes into that hydraulically around that for sure. Again, that's kind of up front of the fired heater, because once it hits the heater, if it's already vaporizing, you've got some passes that are vaporizing, which are going to coke up on you. And yeah, I've experienced that. It's not much fun. And so you got to figure out how to potentially fix that either online or offline, get that coke out of that particular tube, but then also figure out how to operate it more consistently such that, once you get into the heater and you're equivalent all the passes, then you can start vaporizing. You're fine. But if you hit one pass with a ton of vapor, then you got potential issues. So, that's a whole nother story for sure. But yeah, as far as looking at this question, I look at it is what you can do during a turnaround and what you can do while you're in operation. And so the things you can do during a turnaround is try to get back all that design absorbed duty that you were seeing when you started up clean, however many turnarounds, or that last turnaround. That you can ensure, hey, I'm going to get at least back to that point. So that's how you justify the project. If you've lost, 20 million BTU an hour because of fouling, and you know that if you clean, you're going to get that 20 million BTU an hour back. That's how you economically justify that project, right? Because we've run there before. It's not like you're coming up with, some magic numbers that we've never seen before. You're just, hey, we're going to get back to where we were before. If I'm online and I just want to tune the heater up and try to save, make it more efficient, I can look at kind of how I've operated it in the past with my O2s and my drafts, right? And again, there's that it's all based upon stack temperature. The higher your stack temperature is, the less efficient it is based on design. So if you're designed for say a 500 degree stack temperature and you're at 650 degrees, you've lost 150 degrees right there of energy that you could be pushing into the process fluid. So there are some things you can do there. Number one, try to run as efficiently as you can. Anything over design, say 3% O2, is you're basically just heating up air, excess air, and it's going out your stack. Yeah. So the idea is to try to operate that heater at what it's designed for. If it's a new heater, again, you may not necessarily be able to get back to that perfect design condition if it's a 30, 40, 50-year-old fired heater, simply because of air leakage and all kinds of other issues you may have with that heater. Okay, so it's kind of a two-pronged approach. There's, what you can do during a turnaround to get back to original, or what you can do while you're running. Again, all about being safe.
Well, I'm glad you brought that up, John, because that's exactly how we look at it in terms of we all forget about what that heater did when it was new because it was 24 years ago, right? And so that gap, just like the ceramic coating we put on the radiant tubes, we put the tubes back to a new condition. And when you're like new, you are refreshing that whole heater and what it can do for you. And you're holding it in that position for years of performance. And so anytime you can get back to as close as possible to design, even in the lowly convection sections, that is an industry we tend to neglect, if you can clean that and get your coil outlet temperature, your crossover temperatures closer to design, huge financial wins for customers. And taking advantage of that is something, especially nowadays in the industry, is even more important to put that into your scope and into your schedules. We have one more panel question, and then we'll get to some of the Q&A that's been coming in. And this question, I don't know if it's quite fair, because it might be what might be a misalignment, or where is it that we really wish we did a better job as an industry? Because the three of us all sit in different pieces, right? It's different sides of the table. And I'm always trying to find ways to have a better discussion, right? A better cross-functional assessment of issues. And so, Jason, I'll ask you to make a kind of like a final comment on this. Is there anything you would like to see that we sort of do better, just as people in the industry?
Yeah, I think one of the biggest, I say, challenges we have, especially on the purchasing side, or the biggest misalignment, as the question reads, between operations, engineering, and procurement, kind of falls back to the flow of information, right? Because as engineers are working on defining the scope, refining it, getting it to where they want it to be, operations is focused on the rates, right? It's for getting it to maintain and running it at the capacity that it can run. All meanwhile, purchasing's getting, I guess, being asked, hey, start start working on our contracts, start finding our vendors. But this is all done before that we have the full picture of what it is that we're trying to accomplish. That the scope might not be clearly defined. Oftentimes, this happens, right before scope freeze, and then it goes on a little bit beyond scope freeze, right? So we're still, as we're going out with the bid packages, we're constantly having to give a new revision to the bid packages because the scope's getting tweaked, it's getting redefined. Maybe we had we issued it with an IFA drawing, and we haven't gotten the IFCs yet, right? So there's some flow of information that I think we need to do a better job of kind of trapping that, getting all these business units sitting down to make sure we understand what it is to eliminate as much of the risk as we possibly can. So we get more certainty as we're going out for these bids. So I think a lot of it, you said, well, what can we do better? I think it boils down to the cross-functional communication between our units, right? Doing a better job, trying not to work in silos, because we all have our needs and our wants and our directives, but open up that communication line between all of us, as we're all, we're working together, is going to make it more successful and provide more certainty at the end.
Yeah, pushing for over communication, really. That's exactly right, Jason. John, any last comments since you're senior man here on the roundtable?
No, let's get into some Q&A.
There you go. I like it. So I'll let me see if I can't pull that up. By just looking at the sheer volume, I don't think we'll get to all of them, but we can certainly connect with folks. Let's see, here's one. How are other super majors handling inspections and scope growth that stems from identified fired heater equipment part failure, post turnaround scope freeze? I guess it's more a question, but how is this accounted for with these extended runs, right? How are we handling inspection and scope growth that comes from these extended runs? Maybe I'm not phrasing that question right. Can you see that question in the chat, John? It might even be for Jason. Now that we have extended runs on some of these units.
Yeah, that's probably more of a Jason question.
Yeah, because it's not a specific fired heater part failure question.
All right, I found the question. I'm reading it. Give me 1 second.
Yeah, go ahead. While you read that, I'll go to the next one, just give you a moment there. I'm sure you're aware refineries in California are applying CO2, greenhouse gas reduction for credits during heater optimization. But absolutely, that is a bigger part of the industry and continues to grow. It means something. In Europe, we see customers telling us it's $90 a ton for CO2, right? So those are, sometimes the money there can be greater than the fuel savings in doing some projects. So really, it's almost a regional answer, if you will.
Yeah, it is. It's a regional answer, and it's, if those exchanges are set up, I know California has exchanges set up where if I do a greenhouse gas reduction project, by reducing emissions from, one of my fired heaters, I can put that greenhouse gas number into an exchange, and then someone in California will pay into that exchange. I pull that money out and help me do my project. So, unfortunately in Texas, I think per metric ton, it's very low, less than $10. In California, that number is 30 or 40, 3 or 4 times, so that there are definitely opportunities, more so in California than I guess you could say in Texas right now.
Yeah, for sure. Jason, did that question sort itself out, or should we take that one offline?
No, I think I understand it. So whoever wrote it, if I'm missing the mark, please put it in there. But
Yeah.
if I'm understanding your question correctly, what other majors are doing is what we're seeing commercially is they're adding a little bit of that unknowns into the budget and into the cost, right? So some of those unknowns, especially if we're talking about fired heater, we're talking about the degradation of the tubes and whatnot. That's starting to get put into the mud and into the budget. And I think your next part of that is how is this accounted for now that we're extending runs and some more high tone. Where are we at? That we're extending runs and some of our more long-term high profit in the petrochemical units. What we're seeing is reliability getting more involved in the scope discussions earlier. So they're lining out the mindset, shifting from what must we fix now to what can we fix now confidently to run into another full cycle. So what we're seeing more of is we're extending the run length to try to shorten the uncertainty and to extend the profit margin.
Thank you, Jason. I'll pick another one off of the list. It was a question generally, thoughts on cleaning convection sections, specifically soda ash. I'll take that one. There are a variety of, I'll call it in the chemical lane option for cleaning convection sections. Some of them can be pretty effective and can take, I'll say the line of sight light fouling out can be pretty effective, and that may be just enough for what you need in that particular unit. If you want to go to the other end of the spectrum and get that unit back to essentially design, then I would recommend our remote operated vehicle, which is not a chemical scenario. We've had customers where the chemicals used, let's say, mixed with the fouling, and they characterize it as a block of sulfuric cement in the middle of the bundle. And so that's a bad situation. You don't want to do that to yourself. And so our remote operated vehicles can get down into and as deep into the bundles as you build them. So there are other ways, and that's what's important, is to grade out each of the approaches based on cost, based on shifts, based on payback, so that you have eyes wide open. You make your budget go as far as you can for the most benefit possible.
Excessive fouling in the convection section of fired heaters and furnaces results in higher fuel consumption and increased emissions. IGS TubeTech's robotic fouling removal system is controlled remotely. Using a bespoke lance, it penetrates deep between tube rows to remove more than 90% of fouling. With 90% plus surface area clean, there is reduced stack temperatures, less fuel use, lower emissions, and improvement in asset life.
John, this one might tip towards you first. How can we improve the energy efficiency for existing heaters, even the smaller ones, particularly when you're faced with high exit temperatures? Would you want to make a comment on that?
Yeah, I'm assuming the high exit temperature is the stack temperature.
Yeah, I'm not thinking they meant bridge wall, but either way.
Right.
So it's a fair question.
Improving energy efficiencies. Now, as far as turnaround related, some things we can do, the first thing you want to look at is what your approach temperature is. This is key, guys. Approach temperature is simply your stack temperature minus your inlet process fluid temperature, okay? There is a design approach for a heater. Sometimes it's usually in the 20 to 50 degree Fahrenheit range. If it's 150 degrees or 200 degrees or even more, that's opportunity. I immediately see that and I say, okay, what's going on? Is it a fouled convection section? If I scaled up my oxidized my tubes, or my tubes coking up in the radiant section? Or is this an older design heater that I could potentially look at adding some surface area in the convection section? If I can add surface area in the convection section, say some more rows of tubes with more finned area, I can get back that absorbed duty. I've done many projects where you look at that approach temperature, you look at the convection section design, and it's a slam dunk. You can go in, add 2 or 3 rows, or 2 rows, or 4 rows, or 8 rows, or whatever of more surface area, and get back that absorbed duty that maybe it's an older heater, it just wasn't designed the way, technology improves, right? As technology is improved, we can get more out of that heater and make it more efficient. So that's a turnaround related issue there. Again, it's, can I clean it, or is there an opportunity to do a capital/energy project and make that heater more efficient in a turnaround? So again, that approach temperature is the key. If it's online, how can I tune this heater up? Again, it's looking at it, how it's designed. Is it designed for 3% O2? Are you running it at 10% O2? Again, it could be an operational issue, or it could be an inherent design issue, older heater that could be upgraded very quickly and easily.
Awesome. So in the interest of time, I'll make a couple of just wrap up questions here. Regardless of the site or the process train, the fundamentals here are all the same. In Jason's world, right, he's looking at how do you identify the risk drivers on the site to make sure that you get the best scope definition and turnaround outcomes possible. John's leveraging fired heater data, diagnostic software in order to get the optimum reliability and the long-term safety out of that unit. And from the vendor perspective, I'm recommending the optimum processes and qualifying the financial impact after the installation, not only for safe operation, but for your asset life extension. And so I think we can all find a way to collaborate to get the best turnarounds possible.